Okay, today we're going to be talking about solving multi-step equations. So just a couple quick steps right here. The first thing, obviously it says it's optional, would be you could multiply to clear out any fractions or decimals that you may have. Most of our problems today are going to start with just simplifying each side by clearing your parentheses first, and then we're going to combine our like terms. We're going to then add or subtract to isolate that variable term, the letter, right? The variable, the letter term. You may have to move a term with the variable in order to isolate that variable. Then step 4, we're going to multiply or divide to isolate this variable. We're not done until that letter is by itself on one side equal and everything else is on the other side of the equal sign. Finally, you want to always check your solution. All right, so I'm going to do a few of these questions with you, and the rest of them we're going to finish up for homework. All right, so I'm going to leave those steps there just at the beginning to go through them. Okay, notice we don't have any fractions or decimals to worry about here. So we're going to simplify by clearing the parentheses. There are no parentheses. Combining like terms, there are no like terms. We're either going to add or subtract to isolate that variable. Again, there's nothing being added or subtracted, so we're going to jump right to number 4, which says multiply or divide to isolate the variable. So when I look at this question, I see 625 equals 25 times x. So if I'm multiplying 25 times x, to move that to the other side of the equal sign, the 25 to the other side, to get the x by itself, which is my goal, I need to undo that operation, do the opposite operation. So instead of multiplying, I'm going to divide both sides by the thing that I want to disappear. And now the 25s are going to cancel out, and that's going to leave me with x equals, that's what I want on one side. And then 625 divided by 25 is actually going to be 25. Okay, so over here when we look at this one, this has got a 13 minus k equals 36. So in this case, if you were going to solve for the k, what you might want to do is get that k to be positive. You might want to move the k over to this side first, just so that it's positive. But you don't have to. You could eventually end up dividing through by -1. But if it was me doing this problem, the first thing that I would do here is I would get that k to be positive. So again, if we go back through our steps, there are no fractions or decimals, there are no parentheses, we don't have any like terms. So I'm going to add or subtract to isolate that variable. And only because this variable is negative, I'm going to add it to both sides. Now notice how I did not put that k underneath the 36 because they're not like terms. This negative k and positive k will cancel out. So 13 on one side equals 36 plus k on the other side. Now I want this k by itself. This is 36 being added to that k. It's a positive 36, so to move it I would be doing a negative 36 or subtracting 36 from both sides. And again, I am going to put that underneath the common term, and that's going to leave me with a negative 23. So k is going to equal negative 23. Number 3, this problem, again, these 4 right here are very basic, simple problems I'm just reviewing with you. All right, we're going to get into some more involved ones in a little bit. Number 3 says p divided by 20 equals 4. Now notice how we have a fraction here. So what we want to do is actually multiply, right, to clear any of those fractions or decimals. That's what it said up here. Multiply to clear any fractions or decimals. So if I would multiply both sides by 20, I'm going to move this 3 for a second over here. If I multiplied both sides by 20, because just like every other problem we've done here, if you divided by 25 on one side, you have to divide by 25 on the other. If you added k to one side, we added it to the other. If you subtracted 36, we subtracted from the other side of the equal sign. So we have to do the same thing to both sides here. Those 20s are going to cancel out. P is left by itself, and 4 times 20 is going to be 80. And the last step, obviously, I didn't do with you, but we would say, is 25 times 25 625? Yes. 13 minus a negative 23 minus a negative would be like adding a positive, so that would be 36, so that one does check. And 80 divided by 20 is 4, so again, that one checks. All right, the last one of our simple ones here, you want x by itself. So again, what we're doing is adding 10 to this x, so we're going to do the opposite. We're going to subtract 10 from both sides. So x is now equal to negative 14. All right, so those were just the easy kind of first one-step problems. Now we're going to get into our multi-step problems. So again, we're going to quickly look back here. We're going to make sure that if there is something that we have a fraction or a decimal, we're going to multiply or divide. I'm sorry. If you have a fraction or a decimal, you're going to multiply to clear out those fractions or decimals. Your number 2, you're going to check to see if you have parentheses, and if you do, you're going to simplify, usually by using the distributive property. If you have like terms, we're going to combine those like terms on each side of the equal sign. Then finally, we're back to what we just did. We're going to add or subtract to isolate that variable, and then we're going to multiply or divide to isolate the variable, always going back and checking your answer to make sure that you're correct. Okay, so I'm just going to do the odd ones now on this left side here. So if I notice that this has an x plus 6 plus 5x, these are the same, that's a common term. So I'm going to combine those. Notice I'm not going over this equal sign, so I'm not going to change their signs. I'm just going to say 1x plus 5x, that would be 6x. And then this plus 6 is going to also come down, and that's going to be equal to, I have a negative 2 with a positive 2x and a positive 8x. These are the same terms, like terms, so that would be a negative 2 drops down. 2 plus 8 would be 10x. All right, so that was step 2. I combined my like terms. Now we're going to add or subtract to isolate any variables. Well, if I wanted to get those x's on one side and you have them on both sides, I typically find where's the biggest amount of the x's. Positive x's are right here. So I'm going to leave those where they are and move the other ones to become on the other side with them. So I'm going to take the 6 and move it. So I do the opposite. Since I'm going across the equal sign, I have to do the opposite sign there. That cancels, leaving me with the 6 with a negative 2, and this is a 10 minus 6, which would be 4x. I need that x to be by itself, so you're going to hear me say a lot of times, the number with the letter is the last to move, so this needs to move to the other side. Why? Because our directions say we add or subtract before you multiply or divide. So we're going to, when you're solving, it's the opposite of those order of operations. So what we're going to do here is we're going to add this 2 to this side, and that's going to be 8 is now equal to 4x. Now the number with the letter is the last to move, so I'm going to divide, because it was 4 times x, I'm going to divide now. And that's going to leave me, I ran out of room, but that's going to leave me 8 divided by 4 would be 2. And then 4 divided by 4 cancels, so in this case my x equals 2. And if you go back and you say 2 plus 6, that would be 8. And 5 times 2 is 10, so this would be 18. And then we have 2 times 2 is 4, 8 times 2 is 16, that would be 20, and 20 minus 2 is 18. They're both 18. It does check. It does work. All right, now we're going to look at number 7. You can always pause this video and go back if I'm going too quickly for you. All right, this one does have parentheses. So the first thing that we need to do here is distribute, because that means this negative 3 is being multiplied by both of these terms here. So I'm going to bring that in, and I'm going to rewrite this as 39 plus 4r equals negative 2r. Now here we go. Negative 3 times 3 is negative 9. Negative 3 times a positive 6 is a negative 18r. Now I'm going to combine like terms. There are no like terms here. There are like terms here. So 39 plus 4r is equal to a negative 2 and a negative 18 is going to be a negative 20r, and that minus 9. So I got rid of my parentheses by using the distributive property, multiplying that negative 3 by everything inside. Then I combine like terms. Now I'm back to that step where I'm going to try to get my letters together. Well, this is a negative r. I don't like negatives, so I want everybody to be positive. When I'm done solving this, I need it to be a positive variable, positive x, in this case positive r. So I'm going to move that to the other side, so I have to change its sign. I'm going to put it underneath the other r, and then 39 drops down. 20 plus 4 is 24r. Those would cancel, leaving you with a negative 9. If you want r by itself, the number with the letter is the last to move, so I'm going to change the sign of the 39, and I'm going to move that over to this side, put it underneath like terms, and 24r is going to equal, so that's going to be a negative 48. Negative 9 and a negative 39 combined together to give you a negative 48. Remember, when you have the signs are the same, when you're combining, if the signs are the same, you keep your sign and add the numbers. So divide through, this is 24 times r, so opposite is to divide. So if I divide both sides by a positive 24, that's going to leave me over here with an r. And negative 48 divided by 24 is going to be a negative 2. So r equals negative 2 is the answer for that question. Number 9, we have parentheses again, so I'm going to distribute that in. So 3 times 4 is 12x. 3 times negative 2 is negative 6. There are no like terms, there are no parentheses, so I'm just going to bring that down. Okay, there are no like terms again. So I'm going to move my things around. I want my 12x is bigger than 5x, so I'm going to move my 5x to be over on this side. And 12 minus 5 is going to be 7x minus 6 is going to equal 1. The number with the letter is the last to move, so I'm going to move the 6 by changing its sign. If 7x is equal to 6 plus 1 is 7, then when you divide through, your answer is x equals 1 for that one. All right, we'll do some more of these just so that you have an idea. And again, I'm going to leave the other side, the evens, for you guys to do for homework. So getting into some more involved ones here. Same process, so the same steps that we just talked about. Actually, it looks like for all of these problems, we're not having any fractions or decimals, so we don't have to do that first step. That's later on. We are going to clear our parentheses by distributing. We are going to combine our like terms. Then we're going to add or subtract. Again, sometimes moving that variable to get our variables to be on the same side. Then we're going to multiply or divide. Okay, so here's number 11. Let's bring that 5 inside. So 5b minus 40, because 5 times negative 8 is negative 40. Do the same thing with the 6. So it's a positive 6 minus 12b. And that's going to be equal to a b. With a b, we can combine these like terms and get 6b minus 8. I do have some like terms over here also. I have a negative 12 and a positive 5. That's going to be a negative 7b. I also have a negative 40 and a positive 6, so that's going to be a negative 34, and that's going to equal 6b minus that 8. I like my variables to be positive, so I'm going to move the 7 to the other side so that it stays positive now. That's a negative 34 is equal to a 13b with a minus 8. All right, so now what we're going to do is we're going to add that 8 to both sides. And that negative 34, and it's a positive 8, that's going to leave you with a negative 26, and that's going to equal 13b. So finally, remember the number with the letter is the last to move. We're going to do the opposite, so it was multiplying, we're going to divide, and again, I'm out of room, so I'm going to leave that as b equals negative 2. Number 13, let's distribute that negative 2 in to get rid of those parentheses. Negative 2x minus 16 and 3x minus 6. I am just multiplying 3 times x and 3 times negative 2. I multiplied negative 2 times x and negative 2 times positive 8. There are no like terms. I like to keep my x's positive, so I'm going to move that negative x to the other side. Negative 16 is going to equal 5x minus 6. The number with the letter is the last to move, so if we add 6, we get a negative 10 equals 5x. Dividing through by that 5 is going to leave us with a negative 2 equals x. And again, if you go back and you put these negative 2 in for that x, you can solve to see that that does give you the same number on each side. So a negative 2 in here would be a 6, and 6 times negative 2 would be a negative 12. And if I put a negative in here, that's a negative 2, and a negative 2 is a negative 4. Negative 4 times 3 is a negative 12, and negative 12 equals negative 12, so it checks. All right, we're going to finish up these last 3. So it looks like there are no parentheses here, but I do have some like terms. 7x minus 2x, that would be 5x. Negative 7, negative 4, a negative negative is a negative. Keep the sign and add the numbers. Bring that 3 inside. Distribute 3, that's going to be a 9x. 3 times 3x is 9x. 3 times negative 3 would be negative 9. This is actually a negative 1, so that's going to become a negative 8x and a negative 6. It changes the signs, or you can think about subtracting 8 and subtracting 6. No like terms over on this side though, so I'm going to bring down that side. 9 minus 8 would leave me with 1x. You can put a 1 or you don't have to. A negative 9 and a negative 6 would be a negative 15. Okay, I do like my x's to be positive, so I'm going to, since neither one of them is negative, I'm going to take the smaller one and move it to the other side. That will leave me with a positive 4x minus 11 equals a negative 15. The number with the letter is the last to move, so I'm going to move that 11 by changing its sign. And 4x is now going to be equal to 4. And dividing through by that 4, my x is going to equal 1. Oh, this was a negative 4, I'm sorry. Negative 15, positive 11. So this is going to be a negative 1. So that should be x equals negative 1. I forgot my sign there. It was a negative 15 with a positive 11, became a negative 4. We all make mistakes, we're human. That's why I use a pencil. All right, this p and this negative 8p are going to combine to give me a negative 7p. There are no other constants, so I'm just going to bring the 3 down. Distribute that 2 in like we've been doing. 2 times p is 2p. 2 times negative 7 is negative 14. Positive 2 times 1 is a positive 2. Positive 2 times negative 5 is a negative 10p. Again, nothing I combine on this side, but I have a 2p and a negative 10p, so that is going to leave me with a negative 8p. Negative 14 with a positive 2 would be a negative 12, because when your signs are different, we're going to keep the sign of the bigger number and take the little one away from the big one. So 14 minus 2 would be 12, but we're keeping the sign of the bigger number. The absolute value, I guess, with bigger number. So in this case, I'm going to say, they're both negatives. But if I move this to the other side, I would be adding an 8p, which is actually going to be bigger. So I'm going to have more positives. That's going to leave me with 1p and a negative 12. If I subtract that 3, again, my signs are the same. Keep the sign, add the numbers, and I end up with, my answer is p equals negative 15. And then the last one that I'm going to do with you, because again, the rest of them are going to be for you to try for homework. I'm going to take that negative 8, since we've got parentheses, and I'm going to distribute it and get negative 8x minus 40. I'm going to get rid of these parentheses by distributing negative 3 times both of these. Negative 3, negative 5, that's a positive 15. Negative 3 times a positive 8 is going to be a negative 24x. And then the plus 5 just drops down. Okay, now I'm looking to combine like terms. There are no like terms here because this one doesn't have an x. These do have x's. So if you have a 24x, a negative 24x, and a positive 5x, that means I'm going to bring this all down. I'm going to keep that sign of the larger number. 24 is bigger than 5, so I keep its sign. And then I say, what is 24 minus that 5? And that's going to leave me with 19x. Again, I want my x's on one side. This one is bigger. If I move it to the other side, it would actually make my x become positives. So this will be a positive 11x minus 40 is equal to 15. Since the number with the letter is the last to move, I'm going to move this one. I always do the opposite, so they'll cancel out. And this is going to leave me with a 55. And all of these problems were very nice, and they came out to be whole numbers. It is possible now that you are in Math 3 that you may get answers that have decimals. You may get answers that are fractions. You may get decimals, fractions. You may end up eventually getting radicals. You won't always get these nice integer numbers like 5s and negative 1s and negative 15s. All right. Hope this helped. Thanks. Bye.